So in this video, I want to take a little bit of a detour and talk a little bit about something we talked about in the last video, and a little property we talked about in the last video, and that was that the derivative with respect to x of the natural log of x that was equal to quite simply, it was just equal to 1 over x. Now, I have a question, though. What if we wanted to apply the chain rule to this? What if d dx, let's take a look at d dx. What if we took the derivative with respect to x of the natural log of, let's keep it simple, let's just keep it the natural log of x squared. Well, if we're doing the natural log of x squared, we can pretty simply, let's not do simply just x squared. Let's see. Maybe we want to do, I think, let's do, no, we can do the natural log of x squared. That would work. The natural log of x squared. We can get rid of the absolute value because no matter what, this term is going to always be positive. When you square a negative number, you're going to get a positive number. So we can simply get rid of that. But I noticed that we have a little bit, I noticed that in terms of this derivative, we have an outside function and we have an inside function. So I want to go ahead and take a look at, let's go ahead and take a look at what the derivative of this would become. Well, obviously we're going to use the chain rule on this, as I indicated here. And the derivative of the natural log function is 1 over x, but it's not going to be x, it's going to be the derivative of the inside, and the derivative of the inside is x squared. But then we're going to multiply by the derivative of the inside, and the derivative of the inside is 2x. So if we were to simplify that, we would get 2x over x squared. And yes, we could continue to simplify this. We would notice that this x would cancel and leave one factor of x left over and be 2 over x, and we could call it good. But I don't want to move to that step because I'm trying to get you guys to see something very important in terms of the chain rule. I want to leave it like this, just so I can show you guys something a little bit important if we leave it in this form. So I want to do a little something. I want to introduce a variable u. Now, I told you before that you can do u substitution to evaluate derivatives in the chain rule. I personally don't do it that way, right? With the dy dx is equal to like dy du times du dx. I don't even remember off the top of my head. I don't even know if that's the right way, or if it's dx du over du dy. Like, I don't remember. But yeah, again, remember, you could do the du's and do u substitution kind of and do that, and I chose not to do it. But I'm going to do u substitution. I want to try u substitution in this case just to show you guys something important. Well, let's say that u equals x squared. So if that's the case, what does du dx, what does that equal? Well, du dx, that's going to equal 2x. And let's take a look at something. I'm going to take this, but I'm going to move this. I think this needs to go somewhere else where we can view it, but then we can also marvel at some other important concepts here. So we take a look. We notice that, okay, if u is equal to x squared, I notice that in our final answer, there's u. That's u right there. And u prime is right there in the numerator. U prime is right there in the numerator. And so we could rewrite this, if we want to rewrite this in terms of u, we could rewrite this as u prime, I'm going to write this all in green since I did u in green. We could rewrite this whole thing as u prime over u. And so that comes up with another property that you don't have to memorize, and you can derive it the same way as I just showed you right here. It's still possible to derive this, and you can still take the derivative of natural log functions using the chain rule without having to know this. But this rule makes it so much simpler and makes life really just easier in the long run. So you would notice that the derivative with respect to x of the natural log of u, where u is a function of x. I want to make a note of that. where I'm gonna make a text note of that. I'm gonna say where u is, I need to make some more space. U is a function of x. Where u is a function of x, the derivative with respect to x, the natural log of u is going to equal u prime over u. So all you have to do, you don't have to remember that the derivative of the natural log is 1 over x. You can simply just look at the inside and be like, okay, derivative of u, that is whatever it is, and then you can plug the derivative, you can plug the d dx, or I guess d du, up into the numerator, and then you can just take u and place it in the denominator. And that makes the chain rule so much faster to do with natural log functions. So naturally, I always have an example for you guys. When would I ever not have an example for you guys to be able to solve? And so I'm going to go ahead and solve this function. Let's go ahead and say that y is equal to the natural log of x cubed minus 5x plus 3. And we wanted to find dy dx. Well, you could notice that this is the chain rule and that this is the outside function. Well, you should notice no matter what that this is the chain rule and that's the outside function, this is the inside function. Or you could notice and say, hey, I'm applying the chain rule with the natural log function. So when I take dy dx, all I have to do, the only thing I have to do, is take the derivative of the inside and stick it into a fraction. So I'm actually going to do that. I'm going to write it all in green, because if I write it all in green, then, because I wrote it in green earlier with the u prime over u. So dy dx is going to equal the inside, the derivative of the inside, and the derivative of the inside, well, the x cubed is, you're going to bring the 3 down, raise it to the x minus 1 power, which is x squared. The derivative of 5x with respect to x, that's just 5, and the derivative of a constant, that's just 0. And you're going to divide it by u. You're going to divide it by the inside. So we're going to divide it by x cubed minus 5x plus 3. And that would be the derivative of this function right here. So that's a little tip and a little shortcut to help you with finding the derivatives of natural log functions using the chain rule.